Welcome to the Knowledge Find IT viewers. Today we are going to learn about the algorithm regarding the Naive Bayes algorithm. This is another category provided by the Naive Bayes algorithm. The algorithm name is Gaussian Naive Bayes model. We are going to predict the body temperature, the categorical prediction of the body temperature, whether it is fever or the normal temperature, using the Python library. Let's move to the tutorial. First, let me see what is the scenario when we choose the Gaussian Naive Bayes algorithm. If your data set contains the body temperature or the variables like height or weight or the blood pressure, sensor readings, at that point, which means the continuous variables, you can choose the Gaussian Naive Bayes algorithm. Only for the numeric measurement, we can approximately follows as normal distribution with each class. So we can simply say this algorithm will predict the probabilistic classifier. So it will provide the analytical prediction as per the probability. So when we consider the accuracy, this is the moderate accuracy we can get from this algorithm. So the model will train and each distributions for the data set will be gathered, and after the model creation and the prediction we can guess the features. So we can use this model for the data classification, like different types of category. If we consider our scenario is body temperature. So we are going to testify the specific types of body temperature like fever or normal or hypothermia. So there are three categories. We have to identify the numerical values of the temperature, which temperature will comes under this from these following three categories. So at that point we can use this Gaussian Naive Bayes algorithm. So this is the data we prepared under the Google Sheet, and we need to download it as a CSV file. So there are two columns. One is the temperature and other one is condition. There are three conditions. One is hypothermia, another one is normal, another one is fever. So under the temperature, the measurements are located in the Fahrenheit, not in the Celsius. So that is the data we prepared. First, we need to identify the problem type. First, we ensure the classification problem. So the problem type. So that is the classification. We need to classify the types of the temperature condition. There are three types. That is the problem. We need to conclude the problems and find the solution. So the output should be categories. The categories are fever, normal, and hypothermia. So that is the first step we need to do. The second step is preparing our data in the CSV file format. There are two columns. One is the temperature and another one is the condition. That is the categorical label. So after get the data, we need to load the data into the data set using the Python library called pandas. So we prepare the CSV data set. We need to load it under the pandas. After loading the data, we need to spill the data into the data frame. So there are two columns. We need to identify the features and the categorical labels. So when we are finding the feature in an algorithm, there are two variables called x and y. Under the x, we are taking the input feature into the 2D array. And the y is the target label that we need to predict. So when we are predicting any of the variables, we need to consider it in on the y. So that is the target variables. That's why the independent variable is temperature. According to the temperature, we are going to classify the condition of the temperature. If we are entering any of the temperature, we can predict the temperature, predict the condition upon the temperature. So that is the thing we are going to do after splitting the features. So after splitting the features, we need to create the model from the Gaussian NB algorithm. So we are importing all the Gaussian NB and preparing the model. After prepare the model, we need to train the model. So the data is in X and Y. So we need to transform the data into the data frame. So we need to use the fit method to train the model. So after training the model, we come to the final conclusion. We can predict the data using the predict method. So that is the steps. Those are the steps we need to do. Let me move into the practical. So yes, I am going to use the Google Colab as previous. First, we need to import the library. So I'm going to import the library. First, we need pandas because we need to load the data. That's why I need to import the library called pandas. So pandas as PD, that is the object name. So we need to create the object. And another thing, for the modeling feature, we need to use the library called Scikit-learn. So from the package name called Scikit-learn, we can use the algorithm. We need to use the algorithm called Naive Bayes. So we need to mention Naive Bayes. Here we are going to use the algorithm GaussianNB. So continuously we can use the GaussianNB. So that is the algorithm. Gaussian Naive Bayes is a classifier for the machine learning purpose and the prediction we can use. It will shows and analyze the features, and it helps the distribution and used for the classification task without the continuous input variables. So I'm going to run this library, and we are going to use the numerical data. That's why we need to use the import NumB for that purpose. So that's why we are going to use the NumB library. So the another step is we need to read the data. So to read the data, we are going to use the pandas library. So to use the pandas library, we need to create the variable and read the data using the pandas library. So previously we initiate the object called PD. So I am creating the variable data, and we need to read the data. Before reading the data, the thing is we need to download the data. I have prepared the data earlier, so I need to download it. So I'm going to download another CSV format. So first we need to import the data under this sample data. So just click on the folder, this directory icon, and then move to the sample data folder. Then click on this and then upload it. After that, click on the downloads icon. Here you can choose the data. Now I'm going to expand it. Now you can see the data I have uploaded it. Now the data is easy to use. Now I'm going to read the data using the pandas. That's why I'm using the PD. The file format is CSV. So I'm going to use the function called read underscore CSV because the file format is CSV. Under this function, I'm going to copy the path of the file. Right click on the file, just copy path. I'm going to paste it here under this variable. Now I'm going to read the data. So under this data there are two columns, temperature and condition. So I need to extract the temperature column from the data frame as the feature or the input data under the x variable. So I am creating the x variable and the data is under the data variable. So the feature to denote the feature, we need to use the double square bracket because that is the 2D array. That's why I have provided these two brackets. Under this, I need to denote the temperature column name. You should carefully to indicate the column name correctly. So just copy the column name from the sheet, just paste it here. So I extracted the temperature column from the data frame. So I'm going to mention another target variable. Here the target variable is condition. Under the y variable, I'm going to indicate the target variable, that is the condition column. So extract the condition column from the data frame as the target label. We can get any of the column that should be a column we want to predict. So the column contains the class names such as normal, fever or hypothermia. There are three groups of data. So let's run this code. Then I'm going to create the model using the GaussianNB. So initiating the variable called model, and I'm going to use the GaussianNB. That is the function. So we need to use the parenthesis. So I'm going to run this. I created the instance of the Gaussian Naive Bayes classifier. So this model will be trained on the temperature data to learn how the temperature relates to conditions. So then I need to train the data. Using this created model, I'm going to use the fit function. Under this fit function, I'm going to pass the target labels and the feature data. The feature data is X and the target label is Y. So I'm going to pass 2 under this Naive Bayes model. So then the model calculates the statistic, which means the mean variance of the temperature values for each conditions to prepare for predictions. So let's see. Yes, now I need to get the user input to ask the user to input a new temperature value. So I need to initiate the new variable like a new temp, and I need to get the temperature value from the user. So the temperature should be a Fahrenheit, so I need to convert the data type. So I am using the casting. So the temperature is Fahrenheit, so I am using the float. I need to take the user input, so that's why I am using the input method. Under this input method, I am going to use the label called enter the temperature. So now the user can Now the user can enter the temperature here. So the input, which is a string by default, that's why I converted into the floating point number for the prediction. So I'll predict the output. So to predict the output, I'm creating the variable called prediction. So for the prediction, I can straightly use the predict method. So I'm going to use upon the model. So that's why model dot predict function. Under this predict function, I am going to use the new temperature, because for the particular temperature, I need to predict whether that temperature will comes under the three categories like hypothermia or normal or fever. So that's why under this I am going to pass the new temp. So then the users train the model to predict the condition corresponding to the new temperature. The input to predict must be as a 2D array. So the temperature is wrapped inside double brackets. So you should clear about that. After declaring on, I need to print the output. So under the print statement, there is the float, that's why I'm using predicted condition for the particular temperature. So I need to enter the temperature with the string. That's why I'm going to use the curly brackets. Under this I can type new temp. You can use Fahrenheit. The output should be prediction value. So the prediction value comes under the prediction. So prediction is an array. So we need to access the 0 point of the array. So that's why 0 access the single predicted class label as a string. So we are going to use 0. So I'm going to enter the value as 96. So I got the output like the predicted condition for the 96 Fahrenheit is normal. I'm going to rerun it. I'm going to input 120. So rerun it. For the 120, it comes under normal. I'm going to pass 99.32. .32 is the fever. So as per the data, it will calculate the mean of the temperature. According to that, we can predict the temperature, whether it comes under the hypothermia or normal or fever. So I hope you will clear about this concept. Let me meet in another video. Thank you. Bye.